Let's use TVM solver on the TI-83 or 84 to solve problems in which we make one payment into a fund. We deposit $2,000 into an account which grows at an annual rate of 4% compounded monthly. Determine how much we have after 10 years. Now, we've solved problems like this without TVM solver. We can just use the compound interest formulas. But there is a way you can solve these using TVM solver. So let me show you how you do that. Here again is a reminder of how you access TVM solver in case you've forgotten how you access that on the TI-83. Here is a reminder of what all those different functions on TVM solver mean. So again, here's how we access TVM solver. Turn the calculator on, press apps. Let's turn this on. Press apps. Let's choose finance and then TVM solver. And again, here is, the N, the I, the PV. There's what all of those mean. Now, in this particular case, here's what we want to enter. N is the number of compounding periods. Since the money is there for 10 years and there are 12 months per year, the number of compounding periods is 10 times 12. So let's just enter 10 times 12. Yes, I know that's 120, but you don't have to enter 120. Just do 10 times 12 and let the calculator do the tough work. The interest rate is 4%. Don't enter 0.04, just enter 4. It's the interest rate expressed as a percent, not as a decimal. Present value is negative 2,000. Why negative 2,000? Because it's money that's coming out of your wallet, coming out of your pocket. And so any money like that has a negative sign in front of it. It's cash outflow. A payment, there is no regular payment. So that's 0. Future value, that's what we want to know. So that can be anything. We'll just make it 0. Doesn't really matter. Payments per year, compounding periods per year. Well, the number of compounding periods per year is 12. So let's just make 12 for both of those. So again, payments per year and compounding periods per year are the same. Yes, I know there's no payments, but payments per year is just the same as compounding periods per year. In fact, when we enter 12 for the payments per year, we just automatically get 12 for compounding periods per year. Now, the one thing that we want to know is how much money we end up with in the future. So we scroll up to FV and press solve. So it's alpha, enter. And that's what we end up with, 2981.66. So, or 2981.67 after you move the cursor to FV and then press solve. Okay, here's the problem we just solved. $2,000 into an account which grows at an annual rate of 4% compounded monthly. How much do we have after 10 years? That's $2981.67. Now determine how much we would have to deposit if instead we wanted to have $5,000 after 10 years. In other words, we only have $2981.67 after 10 years. If we want to have $5,000 after 10 years, how much do we have to deposit? So let's look at this on the TI. N is 10 times 12. That's the same. That's the number of compounding periods. Interest is the same. Present value, that's what we want to know. So you could enter 0 for that. To be honest, you could probably just leave that alone and it would be fine. Payment's still the same. Future value changes though, because we want to have a future value of 5,000. So let's enter 5,000 in there. And enter. Payments per year, compounding periods per year are the same. So again, we move the cursor to PV and then solve, because what we want to know is the present value, how much we have to deposit initially. So let's go ahead and do that. Let's scroll up PV and press solve. That's alpha and enter. And we end up with negative 3353.83. So that's $3,353.83.